Hey there, I want to show you how to use Bohr diagrams to identify elements and then draw electron dot diagrams from the model. So first let's look at a Bohr diagram. You can see dots on the outside are on these rings called energy levels, and these dots are the electrons. And then you can see the dots in the middle, and these are the protons and the neutrons, and this makes up the nucleus. Remember that the protons are the identity of the element, so we use them to figure out which element they are. In this case, this atom has 1, 2, 3, 4, 5, 6 protons, and so what you would do is you go to your periodic table and find the element with atomic number 6. In this case, it's carbon. So we know that this element is carbon. Now, sometimes Bohr models might be a little bit more ambiguous, and they might not show the number of protons and neutrons, and in that case, you need a different way to figure out which element it is. Well, if we know about protons, neutrons, and electrons, and we know about neutral atoms, we know that protons have a positive charge and electrons have a negative charge. And in neutral atoms, the negatives balance out the positives. So the number of electrons should be equal to the number of protons. So with that knowledge, we can count the number of electrons and also get the identity of the element. So 1, 2, 3, 4, 5, 6 is the same as number of protons. 6 electrons means it's carbon. So that's how you figure out which element it is based on the Bohr model. So let's do another example. Let's look at B. So if we take our shortcut and just count the electrons, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we find number 10 on our periodic table, and number 10 is neon. So we'd write neon in here, and E. So that's pretty simple, pretty self-explanatory, just using the periodic table. Well, the next thing that we need to know how to do is turn these Bohr models into electron dot diagrams. Electron dot diagrams help us when we're working with bonding and when we're working with chemical bonds. And so we try to simplify the model so that we only look at the number of valence electrons, which is the outermost energy level. And so the first thing we do is we just start with the symbol of the element. So we identified that this is neon based on the number of electrons or protons. And what you do is you just write the symbol, so in this case Ne, and we count the number of valence electrons, so 1, 2, 3, 4, 5, 6, 7, 8. We don't count these interior ones because those ones aren't part of the reaction when we have chemical reactions. We only count the ones on the outer shell. So this is 8, so we start putting dots around. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons around neon, so we can see it has a full valence shell. Let's look at another example. We've got 1, 2, 3, 4, 5 electrons. So number 5 is boron. So boron, and its symbol B. So if we make the electron dot diagram, we use the symbol, and then we put the number of valence electrons, which is 1, 2, 3. We don't include these inside ones. So we go 1, 2, 3 dots around the symbol. So that's how you make an electron dot diagram from a Bohr model. So that's an important skill you need to know in chemistry. I wish you best of luck in all of your chemistry studies, and thank you for watching.